So this is in 2-2. Remember that. This is 2-2, and I'll give you homework for it. Plus the worksheet. What time is it?
Okay, we got plenty of time.
Awesome.
Man.
We have plenty of time.
So you can slow down.
Nope, now we go into 2-5. So break lesson here. 2-5. Oops. Can't spell today. I can never spell. What am I talking about? Functions. Well, my problem is I start writing letters that are further down the word than where I'm in with my hand. So I was writing a T here instead of a C.
Yeah, I do it.
I do it all the time. Transformation of functions. So let's say I give you a function f. Let's keep it kind of simple. And the function f is a single point. Now let's make it 2-5. My function f is a single value, a single point. So the only thing, well, maybe I should make it more than that. Wow.
No, you couldn't. Can you just make it simple first so that we can see the idea?
Well, then it becomes kind of hard how I want to write it. Darn it. No, I don't want to start with a single point. Let's start with a couple points. Let's do a graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Need to go down further. 1, 2, 3, 4, 5. But it won't be a huge graph, it'll just be a little baby graph. And this baby graph has a few points on it. And some line segments. So this is my graph f of x. It starts at 0, 0, it goes up to 2, 2, comes back down to 4, 0. Yay! So my first question of the day is this. What if I take my function and I add 3 to it? And this becomes, obviously, another function. It would be the original function plus 3. That becomes a new function. We'll call it g of x. So what would g of x look like when I add 3 to f of x?
It would be the same thing, just over 3.
Now that's the question. Am I going left and right with this? In other words, is the x-coordinate being affected? Or am I going up and down with this? Is the y-coordinate being affected?
Well, we're talking about the x.
Well, the x is here.
Oh,
What's f of x? It's a yawn.
What's f?
If x is the x-coordinate, what's the y-coordinate?
3?
No, if x is the x-coordinate, what's the y-coordinate? F of x. So if this is f of x plus 3, is 3 affecting the x value or the y value? The y value, because f of x is y, so this is like y plus 3. So what is it doing to every y-coordinate? Well, it's increasing it by 3. So g of x would go and take this point at 0, 0 and bring it up to 0, 3. It would take 2, 2 and bring it up to 0, 5, which would be up here. Or not 0, 5, 2, 5, which is up here. And it would take 4, 0 and bring it to 3.
Oh, no. 1, 2, 3, 4.
3, 4, which would be right here. So it takes the entire graph and brings it up 3 units. Every single coordinate, every single y value gets increased by 3 units. Yay! Not that bad, right? It's not bad.
So, okay.
So if I do g of x is equal to f of x plus 3, now what am I doing? Am I affecting the y value?
No,
or am I
you're
affecting
affecting
the
the
x?
x value.
Now this one gets trickier than the y one. The y one's easy, you're just taking y and adding 3 to it. But this one you have to be a little bit more conscious about what's going on. What is the domain of the f function here? What is the domain of the f function? Yes, you need to know how to do this because it will be on the test. What's the domain of f? Where does it start?
Which one you looking at?
The f function, which
I'm
is the
talking
blue
about
graph.
which
The blue graph, f is the blue graph. Green one is g of x. So what's the domain of f?
Is it 4?
0,
0 to
4.
4. Because it's all along the x-axis. It starts at 0 and it ends at 4. Now, no matter what happens, the function f of x can only go between 0 and 4. So whatever I plug in here can only go through the values of 0 to 4. So what you're going to have to do, well, just for this case, is you're going to say, well, x plus 3 has to start at 0, and x plus 3 is going to have to end at 4. It has to. It's the only thing that can happen. I can only plug in values that are 0 to 4. If I solve the first one, I'm going to get x is equal to -3. If I solve the next one, I'm going to get x equals 1. So the domain of g of x is from -3 to 1. So where is this graph moving?
To the left.
It has to move to the left to account for what's going on here. I'm going to draw this one in black. So I'll put black around him. He's going to get drawn in black. So if I take all of these points and I move it 3 to the left, 0, 0 now becomes -3, 0. 2, 2 becomes -1, 2. And 4, 0 becomes 1, 0. So this would be the graph of, I really should give it a different name. Let's call it h of x. H of x. So this would be the graph of h of x. This is f of x. Wait. This is g of x. We're doing this in the barrel.
Right.
So why you have? Can you erase the f of x at the top?
Okay, so on the outside it goes exactly the way you think it's going to go, up or down. On the inside it goes opposite of the way you think it's going to go. Because it's x plus 3, the domain forces it to go to the left to account for all the values between 0 and 4 on the inside of those parentheses.
All right, say that again.
Oh, I'll write it all down in a formula, if you want to say, or a setup.
Set of rules.
So, if you have f of x plus k, k greater than 0, move up. K less than 0, move down. In other words, if k is positive, you're going to take your entire graph and move it up k units. If k is negative, you're going to take your entire graph and move it down k units. Alright, so that's up and down motion. If you have f of x plus h, yes, I'm going to use h in this case. It's a common letter. If h is positive, you're going to move left. If h is negative, you're going to move right. So far, that's all I have. Let me draw a new function over here.
So when you said h is greater than 0.
Positive. Don't say greater than 0. Say positive.
So that's what I was going to ask about.
Yeah, when you see greater than 0, you say positive. When you see less than 0, you say negative. Because if you say greater than 0, it means absolutely nothing to you. Yeah, I got a few minutes. There's a few other things we can do to this graph. So here's the original one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 0, 0, 2, 2, 4, 0. And this is f of x. Put it right next to it. Two more little pictures off of this one. What if I have g of x is equal to negative f of x? What does that do? Well, remember f of x is the y coordinate. What am I doing to every y coordinate?
Oh, wait a minute. I know this one. I know.
Yeah, you do.
No, I do, but
If this is a y coordinate, if y is positive and I multiply it by a negative, it makes it negative. If y is negative and I multiply it by a negative, it makes it. So if it was on the top, now it is on the bottom. If it was on the bottom, now it's on the top. So it takes your original picture and
Drops it.
flips it, reflects it over the x-axis. Now the x-axis points aren't going anywhere. That 2 positive 2 is now going to become 2
Negative.
negative 2. And the graph gets flipped. So this negative here is flip graph over, and I'm going to call it something funny. I'm not going to say x-axis. Over the horizontal, which can be the x-axis, but the x-axis is not always there. We'll get to that in a second. What if I have h of x is equal to f of negative x? Now we have a little problem. Wherever x was positive, now it's going to become negative, and wherever x is negative, it's going to become positive. These are the x values. So which way am I flipping? Over the... I know, but what's that?
I forgot the
This thing.
The line.
What line is this?
That's the
Y-axis. In this case, it'll be the y-axis. Later, we're going to make it...
the graph
Yeah.
over the vertical.
So 0, 0 is not going anywhere. 2, 2 is going to become
Negative 2.
negative 2, 2 over here. And 4, 0 is going to become
Negative 4, 0.
negative 4, 0. So our graph flips over the y-axis. So negative in front of the function flips it over the horizontal. Negative on top of the x is going to flip it over the vertical line, a y-axis in this case.
What are they called? It used to be a term.
Reflections.
That's the reflex.
That's
reflexive
This
one?
is a reflection over the x-axis. This is a reflection over the y-axis.
now,
No, it used to be called something else when we was in elementary.
Oh, good lord.
in elementary,
Symmetric.
Yeah, it was some more names.
But these aren't symmetry. These are actually taking the graph and moving them to a new location.
It says flip graph over.
now is this you got anything to do with the even odd stuff?
A
Reflections?
little bit. If it reflects over the y, it's not. See, even in odd functions are the entire picture.
Okay.
This is taking whatever you're given and flipping it over the y-axis.
All right, so it's the same.
Same idea, but you're not getting the picture. You're not saying the whole picture is even, the whole picture is odd. You're saying, I'm taking this function and moving it.
All right, so what's the
This one?
Yeah.
Flip or reflect graph over the vertical. Now I'm going to tell you why I'm calling it horizontal and vertical,
And not X and Y.
and not x and y. Yeah, there's a reason. So let me just give you one last example.
And flipping it is it's really just that's what you're calling the reflection.
Reflection.
Okay.
Mirror
So
image
you're
on
dumbing
the
it down
opposite
by
side.
saying flip.
I like saying flip. So what if I have, I don't know, q of x is equal to negative f of x minus 3 plus 2. Now we're doing everything to it. Original graph, that blue one, 0, 0, 2, 2, 4, 0. And I want to do this to it. And this will explain why I call it horizontal and vertical over there instead of x and y axis. Let's do it one piece at a time. What is the 2 doing? The plus 2 here at the end.
It's bringing everything up
Up
by 2.
2 units. Okay. What's this negative 3 doing in here?
It's bringing, making it go that way.
The one on the inside does opposite of what you think it's going to do. It's negative 3, so you're thinking left, but because it's on the inside, you have to go
To the right.
to the right. So this is actually right 3. What is this negative doing? Well, this is a flip, for sure, because it's a negative on something. What's it flipping? Is it on the outside or is it on the inside?
It's going down.
So it's flipping over the horizontal. So we're going to call it a horizontal flip. Okay. Now the reason I call it a horizontal flip is this. When you say right 3, I highly suggest you put in a nice little guideline, x equals 3. Nice little vertical line. And basically what I'm saying here is I'm taking the y-axis and I'm moving it 3 units to the right. The entire y-axis, shift it over. The up 2 is going to give you a guideline right at y equals 2. And some books will call these imaginary axes. Like this was the imaginary x-axis. Some books will call this x prime, though I don't like that. This is the imaginary y-axis. They'll call it y prime. But you don't have to get into that if you don't want to. Just put the little dotted lines as reference. Now this graph is moving 3 to the right and 2 up. So every one of these points, original points, are going to move 3 to the right and 2 up. So the 0, 0 ones are actually the nice ones, the 0 x-intercepts. So 0, 0 is going to move to here. Because it's going to move 3 to the right and 2 up.
We need graph.
Graph paper is wonderful with this stuff, but don't worry about it. Now we have to worry about one thing. This 2, 2 is going to move 3 to the right and 2 up. So 2, 2 is right here. 3 to the right would bring it to 5. 2 up would bring it to 5, 4. But there's that negative in there. So when I'm talking about flipping this point, I'm talking about flipping this point over the horizontal, this dotted line, not the x-axis, which is way down here. I'm flipping it over the horizontal. So here it's 2 up, so it's going to swing to be 2 down. Now if I go from 4, 2 down, where would it be?
If you go down 2, it's going to be on the 2.
It's going to be
Right there.
right here, the x-axis. It's right on
Right on the X.
5, 0. It was supposed to be at 5, 4, but because you're flipping it over that green dotted line, x prime, it's going to end up at 5, 0.
Yeah, what's the point of the dot line there?
Dude, did you really?
That's what we're reflecting over. That's what we're reflecting over. So since this is 2 units away from the dotted line, when we reflect it over, it's going to be 2 more units. So because it's 2 up, it's going to go 2 down. That's a reflection over the horizontal line. And then the last point is 4, 0. So when it moves 3 to the right and 2 up, it's going to end up at 3 to the right.
Hey.
Well, you're at 4.
Oh, yeah, 4.
3 to the right would be positive 7. And 2 up would put it at 7, 2. So your function looks like this now. That's all the time I have for you right now.
Wow.
But this is all that's going on with this little baby graph. Home transformations. Quick little review. This is what, 2, 5? And just a quick review of what we were doing. We took 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We took a very simple function, and I'm going to draw it a little different today. Let's put it here. 1, 2, 2 here, and here. So this little baby graph, which has coordinates -1, 1, 1, -1, and 2, 1. The beginning coordinates. We'll call this f of x. My blue marker's dying already. Running out of blue markers. so let's call this f of x. What's the domain of f of x?
The domain of f of x.
-1.
-1 to +2. Starts over here at -1 and works its way over here to +2. That's a little high. What's the range?
The range is +1 to
Oh, +1 and +1?
No,
+1 and -1.
you read it backwards.
-1 and +1.
-1
Wow.
to +1. It goes down. You always start lowest to
Hi.
highest, so it's -1 to +1. All right, so if I want to graph a new function called g of x, and it happens to be related to f of x this way, what's happening to it?
It's moving down.
It's definitely going down 3.
It's going down by 3.
So down 3,
And left 2.
left 2, opposite of what you're thinking of it is. What's the negative do out front?
Flip the graph.
Flips it which way? There's 2 directions you can go, up to down or
Over
left to right,
horizontal line.
over a horizontal. So it's going to flip up to down. Okay, so all I need to do is take that picture and move it in this way. So if I take that picture, be a little bit more cautious with my marks. What's that? Where is it going to go? Now, one way you can deal with this is a point-by-point way, but that gets a little confusing. So I'm going to do the imaginary axis thing. It's going down 3, so the whole graph is moving down here. It's going left 2, so the whole graph is moving in that direction. So you can kind of think of the black axis shifting into the green ones. And then the flip is the hardest part. So I'm going to graph it without the flip first, and then graph it with the flip afterwards. So without the flip, where is this graph going? Well, -1, 1 is going to have to go down 3, left 2. So if it goes down 3 and left 2, where am I? -3, -2. So let's see here, -3, -2. That would put the point here. Now this is not my final graph, I'm just moving the points without the flip. 1, -1 is going to do the same motion. It's going to go down 3 and left 2. So where does that put it?
-1,
-1, -4. So -1, -4, that's right here. And then finally, 2, 1 is going to do the same motion. It's going to go down 3, 3 and left 2.
2, 0.
Careful.
-2. I mean
Careful.
negative.
0, -2.
0, -2. It's a y-intercept. So 0, -2 is right here. So without the... that doesn't look right, does it?
No.
What happened? I screwed up someplace. Down 3, 1, 2, 3, left 2, 1, 2, that's right. Down 3, 1, 2, 3, left 2, 1, 2, that's right. Down 3, 1, 2, 3, left 2, 2. -3, -2. Maybe I just scaled this really badly. I think this 1 is too close.
Question.
I think the scaling on my picture is just bad. Like, I think this side is too big and this side is too small. So we'll just have to go with what I got. We'll move this point over a little bit. All right, so we get this picture down here. With graph paper, it comes out a lot nicer. Thank God on the test I give you graph paper. All right, now we need to flip it. So what was high is now going to go low, and what was low is now going to go high. So this thing is how far away from my little green line? 1 unit. So it's going to flip exactly 1 unit down. So it's going to end up down here at a coordinate of -3, -4.
It doesn't flip on the middle. It doesn't flip on the middle point. On the-
It flips on the horizontal line. That's why I put this horizontal line in here. It's going to just flip right over it.
So if I didn't do that one, I'd be around.
All right, this one is 1 low, so it's eventually going to end up 1 high. It'll go up here. This will have a coordinate of -1, -1, -2. And then this one is 1 high, and it has to go 1 low, so it ends up down here. So this is the final picture. This would be g of x. It just flips.
It doesn't.
It's flipping. I mean, if you look at it, it's like saying,
to me would be a total
Here's
mirror
a-
image of the.
here's a dotted line. If I take that shape and flip it, what do I get?
Now
Why?
you flipping it vertically?
Horizontal.
Okay,
It
and
looks
you
like
gotta
a
get an
Y.
A.
It will look like an A.
Huh?
A sideways A.
If you flip it
Yeah,
horizontal.
that's what I mean.
Oh.
That's what I'm talking about. If you do.
Yeah, I'm doing that. I'm taking this black shape and flipping it over this green line. It's rotating over.
Over the middle
this.
of that, so the center point of the vertex.
Could care less about the center point and all that other fun stuff. It's just flipping over the horizontal. You flip it over the center point, you're actually flipping it over the vertical. You're rotating it around the y-axis. You don't want to do that.
So I think my biggest problem is the horizontal and vertical. Like, cause you know I struggle with what's horizontal and what's vertical.
Horizon.
That's how I think of it.
You go out to the ocean and you see the
Yeah.
horizon, so therefore it's horizontal.
Oh.
And that's how I remember it. Otherwise, I just want to which one's which. Let me give you something. Maybe this
Yeah,
will.
because you didn't never give it to us last week.
What?
You said you was gonna give us
I said
something.
it was up here.
Oh,
Oh,
I got graphics.
I know what you're talking about. I'm going to put that on the line. Keep forgetting. That's super important, but
There ain't one.
this way your pictures will come out a little bit better. When I make my video, I'm just going to do a picture. Done with it. Make it perfect. Okay, what I want to do to this thing now is what happens if I take h of x, and I'll try to draw the picture a little bit more cautiously, and I put 2 in front of f of x. What happens when I multiply it by 2? All right. 1, 2, 3, 4, 5. 1, 2, 3, 4. I hope this fits. It should. 1, 2, 3, 4, 5. 1, 2, 3, 4. That looks more even, doesn't it?
Not top and bottom.
Well. You draw yours on your graph paper, and that way it comes out nice. Okay, so first things first, I know the coordinates over there. That makes life a little bit easier. What do you think this 2 does to f of x? Does it affect the y value, or does it affect the x value?
If you're gonna give us so it's the y
It's
value.
going to affect the y value because it's multiplying f of x, which happens to be,
Oh no.
Y.
Oh,
because the x is inside, f of x must be the other variable, which is y. We've talked about this a lot. So this is going to be 2 times whatever your y value is. So your domain's not getting touched. Your domain is still -1 to +2. But every one of your y values is now going to double in size. So that coordinate -1, 1 becomes -1,
2.
2. So we get -1, 2. This becomes our first point. 1 -1 becomes
1 -2.
1 -2. And 2 comma 1 becomes
2, 2.
2, 2. So we get this graph that looks like this. Now the original one, let me put the original one in there, was here, here, and here. This would be the original one. So when you multiply a function by 2, it stretches it along the y-axis. I consider that this is going to be closer to vertical. Closer to the vertical. I'm multiplying it by 2, right? What happens if I multiply it by 1/3? What if I have And this is, let me label it nicely. This blue one is h of x. Let's do a black one. What if I do, let's call it f of, I can't call it f of x, g of x is equal to 1/3 of f of x. Well, what happens to my coordinates then? Well, negative 1, 1 becomes negative 1. You're taking the y coordinate and multiplying it by 1/3. So negative 1, 1 becomes negative 1 and 1/3. It's like right here. And 1 negative 1 becomes 1 negative 1/3. It's like here. And then this one, which is 2, 1, becomes 2 1/3. It gets right about here. So you get this graph.
Nice. We get the idea.
I think I screwed up my point.
Maybe you need to get
No.
that graph form. There's your graph form
That
right
thing
there.
stinks. Your eyes will go crazy. It's not that far off. 1, 2. Oh, you know what it is? I put this point too close. I wanted it further over. That's all right. So what happens to the graph is, instead of getting tall along the y-axis, it's getting short according to, or closer to the x-axis. So if I multiply by 1/3, I'm going to consider that closer to horizontal. It's closer to the horizontal. And the reason I say that is because we're going to be shifting the graph all over the place, and we're not going to have an x-axis and a y-axis anymore. We're going to have these imaginary ones. So the rule here is pretty much this. If we have g of x, and it's equal to a f of x, you're going to get closer to vertical when the absolute value of a is bigger than 1. Why do I do the absolute value? Because I could care less if it's positive or negative. Negative only takes the graph and flips it over the horizontal. That's taken care of already. So we're worried about just the absolute value of the number in front of the function. It's closer to the horizontal when, I have to write it this way, but pretty much you can say less than 1. I definitely don't want a equaling 0 because then you won't even have a function. So when a is between 0 and 1, what kind of number are we talking about usually? Fractions, but the fractions have to be less than 1. Like on my quiz the other day for my other class, the fraction was like 5/4. And they made it closer to the horizontal because they saw a fraction, but it should have got closer to the, because it's bigger than 1. Yeah, so you have to be careful. As long as the number is bigger than 1, it has to get closer to the vertical. So let's try one more. A horrid one. Let's do everything I've taught you so far. G of x is equal to negative 3/2 f x minus 3 plus 2. I think that takes care of most of the things I taught you. Alright, the original coordinates were negative 1, 1. What was the other one? Negative 1, 1, 1, negative 1, and
2, 1.
2, 1. That was our original f function. You want to think of it that way, with the line segments connecting. Okay. So, let's see. 1, 2, 3, 4, 5. 1, 2. Ugh, that one's off. 2, 5.
Can I ask? I don't know. I missed. Where did you get those coordinates? Did you just fabricate that?
I just
first.
You first graph, yeah.
You
The
just put it up
coordinates are
there.
given
I
to
have to give it to you. I have to give you some kind of graph.
You didn't pull those coordinates out of that x equals 2fx.
It's the original picture I gave you.
You gave us the original.
Negative 1, 1.
Okay.
1, -1, and 2.
I was just trying to figure out how you made those coordinates magically appear.
They didn't magically appear. They're the ones I've been working with for all of these.
All right.
Okay, now, when you're doing this, the first thing you do is you ignore this number out front. You have to, otherwise it's going to mess you up. You deal with that at the very end. There's a flip. What's the 3 do? Goes to the right 3. What's the 2 do?
Goes up to.
Goes up 2. So get your imaginary axes in here to begin with. You go up 2, you go right 3. So your whole picture is going to get shifted to this zone.
If it's positive, it goes to the left. If it's negative, it goes to the right.
Inside it goes opposite of what you think it's supposed to do. Alright, so let's graph f of x minus 3 plus 2 and then deal with the other 2 motions. This is going to take a few pictures, so be cautious with it, how you draw them. Well, maybe we should do the flip while we're doing this too. Let's deal with the flip while we're doing this so we can get the shape in the right location. So we're going to take -1, 1, we're going to move it up 2, right 3, and flip it over the horizontal. Flip it over the horizontal blue line here. So the first point we're going to take is -1, 1, and we're going to move it up 2, so 1, 2, and then right 3, so 1, 2, 3. And we get to this point here, but then we're going to flip it, so it's 1 high and it's going to end up 1 low. So we're going to get this coordinate, which is 2, 1. All right, that's just the first coordinate. Then you take 1, -1, and you, where is it? 1, -1 here, and you move it up 2, right 3, and then you flip it so it ends up here at 4.
See, I went the other way.
Other way, which way?
I mean, I went down instead of up. So, okay, I just take it up 1, and that's going to be 3, 4.
1, -1. You take it up 2, right 3, and flip it. It's going to be 4, 3. 4, 3. You take 2, 1. 2, 1 is, well, here. And we're going to move it up 2, right 3, and flip it. It ends up here. Now this graph I'm going to draw in as a dotted line. This is not the graph that I need. What I need is 3/2 of this. Now I'm not going to be precise with it, I just need to put it in the right location. So if I 3/2 all of these coordinates on this graph, which way does it go? Does it go towards the horizontal or does it go towards the vertical? And away from the horizontal. Towards the vertical, because 3/2 is bigger than 1.
Yeah.
It's bigger than 1. So I had 2 options to move this point. I could move it closer to the horizontal upwards, the first point, but because it's 3/2, I'm going to move it the other way. And I'm just going to kind of move it someplace. I don't know precisely where it's going to land. Technically it's 1.5, but you don't have to worry about that. This one's going to move. Which way? Down or up? You guess up or is it up? If it goes down, it's getting closer to the horizontal.
So it goes up.
It has to go up, so it's up here someplace. And then this one has to go down. It's going to go down here someplace.
I don't get your little guessing thing though, like.
It's not guessing.
No,
It's getting closer to the vertical. It's going away from the
because it's a
horizontal.
negative.
But it doesn't go up 3 every 2 or anything.
No. This is not a slope. This is a factor. You're multiplying every coordinate y value by 3/2. That means it's going to be
every
3/2
y.
as big.
Okay.
Right. Yeah, 3/2 as big.
Because how is negative 2/3 bigger than
3/2.
3/2? Negative 3/2 is bigger than A.
Absolute value of it. So the absolute value of negative 3/2 is 3/2. Yeah, the negative just tells you you're going to flip. That's all
That's
it
right.
does.
Okay, all right.
All right. Now let's go into pictures that you have to memorize.
Huh?
You have to memorize.
Memorize
These
what?
are called base functions. So the base functions the nice thing about line segments is you can count. You can actually take each individual point and move it around. Base functions, you don't have that nice option because you only get to plot one point. Those you can plot as many as you need. So the first base function is x squared. Actually, technically, the first base function is x, but that's kind of boring. It's a straight line. And the picture of x squared looks like this. Starts at the origin because if you plug in 0, you get 0. What happens when you plug in negative values of x? Like negative 1. Well, what's negative 1 squared?
Oh, it makes it positive?
It makes it positive. Negative 2 squared, 4. Negative 3 squared, 9. So on this side, it actually has this kind of shape. And the same thing happens on the other side because they're positive to begin with, and then when you square them, they just become positive again. So f of x equals x squared looks like this. This little piece you have to be really careful. The only point you get to plot is that one, the origin point. If you start plotting points on the rest of the graph, I mark it wrong because you're not doing what I'm asking, which is sketch the graph. I'm not asking you to graph these things. I'm asking you to sketch these things. So that would be the base function x squared. Another one is x cubed. X cubed has a picture that looks like this. And the base graph starts at the origin, because if you take 0 and plug it in, you get 0. What happens when you plug in 1?
It becomes positive.
Positive 1. What happens when you plug in 2?
Positive 4.
2 cubed.
I'm sorry, positive 8.
Positive 8 goes way up here. Now, I'm plotting points here just to get you the idea of what the shape's going to be, but these two you do not plot when you graph this. What happens when you plug in negative 1?
It becomes negative 1.
Negative 1, negative 2?
Negative 4. I'm sorry, negative 8. I
Did
keep
that
doing
earlier.
it.
Negative 8. So the graph of x cubed looks something like this.
Because it goes across the origin, so that makes it negative.
It has nothing to do with that. It's odd. I'll give you that.
I mean, that's what I meant.
Yeah, it's odd, but the general shape is this weird squiggly. It's hard to describe. But the only point, again, that you're going to graph is the center one, the 0, 0 area. But you have to understand the general shape of x cubed. The next one is, let's put the square root of x here. Square root of x. Can you take the square root of negative numbers?
It turns them into I.
Yeah, but then you can't plot them. So nothing to the left of the origin is going to work. Can I plug in 0? Yeah. Square root of 0 is 0. So we get an origin point again. All of these graphs start at the origin, by the way. Square root of 1? 1. Square root of 2? Oh, yuck. I don't like square root of 2. Square root of 3? Square root of
4.
4. Square root of 4 is 2. That's way over here.
That's positive.
Square root of 9 is 3. It's barely climbing, so you get a graph that looks like that.
But you said do
it's a
not
very
plot the point.
Do not plot the rest of the points. You only plot 0, 0, and it has this general shape. Alright, how about, I'll put this one up here. F of x equals the cube root of x. Cube root of x. Can you take the cube root of 0?
Yes.
Cube root of 1?
No.
Yeah, why not? Cube root of 1 is
1.
1. What's the next cube root you know?
9.
That's the square root you know.
8. 2 and 8.
2 and 8. So it's going to go up to after you get to 8. So it's got a very low threshold, much smaller than the square root of x. So it goes off in that direction. Can you take the cube root of negative 1?
Yes.
Yeah. What's the cube root of negative 1?
Negative 1.
Negative 1. Cube root of negative 8.
Negative 8. Oh, you said, I'm sorry.
Cube root of negative 8.
Negative 2.
Negative 2. So you get this graph that goes that way.
Sound like you said cube root of negative A.
Negative A.
It's all right.
Negative A. I think this is the last one. F of x is equal to the absolute value of x. Probably the easiest one out of all of them. Absolute value makes things positive. If you just looked at y equals x, what kind of line is that? Y equals x.
It stands up, so
It's not vertical.
horizontal.
I like her. This, yeah. Has a slope of 1. So it goes up 1, over 1, up 1, over 1, up 1, over 1. And it starts where? Well, at the origin. So it looks like that. And then when you go to the other side, it has to stay positive, so it wants to come down here into the third quadrant, but this absolute value forces it into the second quadrant. So you get this. So you get a V. You get a V out of it. Okay, so what am I going to do with these base functions? And I'm going to transform them now. Move them all over the place.
Oh no.
Not horribly so. For instance, we should be able to graph g of x is equal to x plus 3 all squared minus 4. Easily. Much easier than moving the points around, by the way. So, we know what the base picture looks like. You know, it's something that looks like an x squared graph. X squared has this general shape. What's happening to this general shape?
Means moving
It's
down
moving
4
down.
Down 4
and to the left 3.
and left 3. And there's no flips, and there's no getting closer to the horizontal, no getting closer to the vertical. This is a very nice one. So when I graph this, I'm only interested in left 3, down 4. And I'm,
the only time he flips when there's a negative, right?
The only time you flip is when there's a negative on the outside, and then there's that weird case when there's a negative on the inside, but I don't like talking about that one. That gets most people confused. So left 3, down 4, the origin point moves here. That original origin point has gone and shifted itself over to this position. And then the rest of it is, you draw that shape.
That's easy.
So the shape is, woohoo! And you're done.
Good. Skip the
Woo,
hard
I
part.
can't believe it's something easy.
No, skip the hard part.
I know it's gonna get hard.
The points were the hard part.
Yeah.
But it gives you an idea of how things are moving around. Now I can
have
just,
to remember the original
all that fun stuff.
base or whatever.
But the point one is the one that I showed you how to do all this stuff, and now we can use it to do these rather quickly. How about g of x, or let's call it h of x. H of x is equal to negative
Oh, now we're gonna flip.
the cube root of x minus 2 minus 3. Everything's negative.
We're gonna go down
Down
3,
3.
Down
to
3,
to the right 2,
right 2,
And flip it.
and flip it which way?
To the other side.
to the horizontal.
Horizontal. You say the other side, I start thinking
Vertical.
over the
Now,
y-axis.
how did I know it was horizontal?
Because it's out in front of the function. If it's inside the function on top of the x, it'll be vertical, but I don't do very many of those because they're very tricky. All right, so I need to move this thing right 2, 1, 2. I need to move it down 3, 1, 2, 3, and I need my reference lines for this one. It's a
Yeah,
weird
flip it.
graph. Well, because it's a weird graph. So let's see here. Reference line here at y equals negative 3. Reference line here at x equals positive 2. And it's a cube root, and that's why I like my reference lines. Because cube root's not as nice as a parabola. It's that low squiggly thing that goes through this point. I know where the point is now. Normally, it goes bottom here through this point and then on top, but it stays really, really low. But it's being flipped, so it's going to be on the other side of the blue line. So it comes in this way, goes through this point, goes down this way. And that would be the graph, or a sketch of the graph, of h of x. Isn't this easy? It's all right.
Well,
Now, I
the
can't
only reason
believe
it's a
it.
sketch is because we're not having to.
I am not plotting any other
We're
points
not figuring out any other coordinates.
except for that
except
one.
for the origin.
And this, if you graph this on a graphing calculator, this is generally, well, cube roots don't graph very well on graphing calculators, but this is generally what the picture looks like.
So you can graph these on the graphing calculator?
Heck yeah.
Okay, can I go to
But
my calculator?
They don't come out like this one, some graphing calculators only graph half of it.
Gotcha.
I don't know why, but they do. Some do. Graphing programs do. I know that. How about if I graph a function that looks like this? And this is what one of my test questions is. 5 minus 1/2. Which function? Let's do cube. X plus 2 cubed. Yeah, that's it.
Okay, so we're going to
Wait, you gotta multiply. Wait.
I know we're gonna go to the left too.
Left 2.
Are we
And
gonna
then
go?
up 5.
Up 5. It's outside. Who cares what side it's on?
Yeah.
It's still a positive 5, so it's increasing the value by a positive 5. What's the negative do?
It makes it be horizontal. It's gonna flip it and it's gonna be horizontal.
Flip over the horizontal. What's the half do?
We're gonna flip it by half.
Nope.
Make it move. I mean, wait, not move. Yeah, you move it. What is it? To the left one?
Closer
To
to
the
the
horizontal.
horizontal.
Oh, closer to the horizontal.
Look at it.
Less
Yeah,
than one.
no.
Closer to the horizontal, because it's less than 1. 1/2 is definitely less than 1, and it's bigger than 0. Okay. Now this is going to require 2 pictures. One without the 1/2. You have to leave the 1/2 off and put a dotted line in, because you have to kind of show that you're either going closer to the vertical or closer to the horizontal. So the way I write it on my test is, I want you to sketch this graph, but first graph g of x without the 1/2 as a dotted line. So it works out that way. So let's see here. Up 5. Oops, wrong color. Up 5. 1, 2, 3, 4, 5. And left 2. 1, 2. Notice I don't even put any other marks on my x and y axis. I just put the ones in for the motions. That also is an indication you're just sketching. So I need a horizontal line here, a vertical line here, and I'm graphing a cube graph. So if I'm graphing a cube graph, cubes usually start at the bottom left and go through the middle and go up in the top right. They have this general shape that looks like this.
Did you say left two?
Did I do something wrong?
Yeah, and it's supposed to, oh, never mind. That's my bad.
So the cube usually looks like this. It starts at the bottom left and goes up through the top right. But because it's being flipped, it's going to start in the top left and come through the bottom right. So the original, or the without the 1/2, it's going to look like this. It's going to go through this point, and it's going to go on its merry way. That would be without the 1/2. Without the 1/2. With the 1/2, how do I get closer? Like, say I take this point here. How do I get closer with that point to the horizontal? Do I go to the, come down, right?
Mm-hmm.
So if I come down, my graph is going to stay on that side of the dotted line. Because if I go on this side of the dotted line, I'm getting closer to the vertical line. So I'm going to move this graph on this side, and you get the final picture. Looks something like this. Ooh, what about over here?
It has to go to the left also.
This way?
Uh-huh.
But if I go this way, what line am I getting closer to?
Vertical.
That's the vertical, so I have to take this and
Dotted
go this way, because it's getting closer to the horizontal line. This being the horizontal line.
Oh, gotcha.
If I want to get closer to this horizontal line, which way does the graph have to go?
Up.
Away from me or towards me? Towards me. So it has to come this side. So this black graph is our final picture. This is f of x. The green dotted line is just there to show that I actually did take it and put it towards the horizontal. That's the test question-ish. That and maybe a line segment thing.